Hello everyone. Okay, I think so. I am audible right now. So I will start the session from here. So before starting, I will give some basic instruction to you that how this session get progress and what are the other things which I am discussing today. And after what I will start the session. Okay. So first of all, and those who are new, my name is Sumit Kumar. I am PMR research scholar at IIT Islamabad. I am taking the course of Geotechnical Engineering, which is taken by Professor D.N. Singh sir from IIT Bombay. So I am discussing those sessions over here. I am solving the problem and also interacting with you. And so you can get the better idea. And if you have some doubts, you can ask me over here. I also discuss the concepts, those which are discussed during this week, as well as I also take care of some of the revision of the previous week as well in the quick revision portion. So you are good aware with that. And some more instruction I want to give that if in any case due to any network issue I get disconnected, so please be remain there in the meeting. I will rejoin the meeting and I will complete the session. So it is not mostly it is not happening from the last four session to today is the fifth session, but last four sessions go smoothly. But if in any case that happens, so please be there. Okay, some more instruction I want to add for those who are here as well as those who are going to watch in YouTube. So I will give the instruction in a starting. So when you start watching the video, you will be aware that what are the things I am taking care of. So whatever the content, whatever the video I am recording over here get uploaded on the YouTube, and the content which is discussed by me, the presentations files is also shared with you by the NPTEL team. And any more query, whoever not here are can also ask me over there as well at YouTube as well as by contacting me by emailing me. Okay, and some more portion I want to add, like what I today going to discuss. So first of all, in starting 5 to 10 minutes, I will discuss the concepts which we have discussed during the last four lecture. I only take the key concepts. I will go through the slides and I will revise the key concepts for 5 to 10 minutes. So might be in the meanwhile some more people join. If not, those who are watching for the first time on YouTube also get benefited. They don't feel blank. And apart from that, afterwards, today we are solving approximately 13 to 14 problems. Very good problems, which will help you to get those are the problems which consist of the concepts which are asked in the different competitive exam, as well as if you are in any institute over there also those types of problems are asked on a regular basis. So we will discuss those problems that will clear your concept, because we have discussed the triaxial test, Western test, and diaxial test, and we have also taken the sum of the problem. But today we are primarily focusing on solving the problem in the last 45 minutes of today lecture. Specifically, in a second hour of the today's session, we are going to discuss the problem only. So please watch this session. Those who are watching on YouTube, also I want to give you clear instructions. Please watch at least the second half of the portion, so you will get benefited. You will find the practical implementation. What are the problems that can be framed on the given topic? And one more important aspects I want to add, like we are successfully landed on the moon. So this is a great achievement for our country. And on that moon surface as well, the geotechnical behavior is uh, found by our Chandrayaan 3 missions, because what are the minerals over there and what are the waters, if the water is there or not, that is the Vikram and Pragyan is going to research on that. So in one aspect we can say that the geotechnical aspects is studied by the Vikram and Pragyan rover and Vikram lander over there. And with the help of images, we also come to find that there are too much and evaluations, and the rocks are there, what type of characteristics are there. So we are got to know about those things. So this is a very proud motion, proud moment for our country, for each and every individual, so that we have achieved this feat of successfully soft landing on the moon. So this is also one of the very good aspects. And with this note, I will start the today's sessions for taking the starting with the basic concepts. This is 311, so we will end by 320 the revision session, and afterward we will go with a new content and the some of the very good problems with you. Okay, so let's start. And one more point, at any point of time, if the audio and video will be disrupted, so you can ask me. I will take care of that. Otherwise, I have also joined from another account of myself only to take care of those things. So I will be aware that if any discrepancy occur in that case, so I will take care of that. But if any problem arises from your side, you can ask me and I will take care of. And if any doubts is there, you can write in the chat box. I will take those doubts at the end of the session. Okay. So first of all, I will take a short revision session and of approximately 5 to 7 minutes, and afterward I will start with new contents. I think so. My slide is visible to you. Yes, yes. I am also able to see that my slide is visible. Uh, Give me a minute before I start discussing. Okay, I think so. Slide is visible. I can also see that. So I will start over here. So first of all, the this session basically this course started with the shear strength of soil, and we have discussed the shear strength. What is the shear strength? On which parameter like cohesion and angle of internal friction is different. We have also discussed the different type of tests which are performed on the soil. That is the triaxial test and direct shear test. We have also taken the consideration of vane shear test. Today we are going to solve the problem on the direct shear test, vane shear test, and direct shear test. Sorry. And we have understood why it is so important, why shear strength is so important, that at every aspect we are talking about the value of shear strength, how the shear strength is important in any of the structures. Because if we designing the superstructure, if you want to study the superstructure, so we must be aware about the substructure characteristics. Afterward, we will say that this much of load can be taken by this structure, and on the basis of that, we can act. So we need to be aware about those facts, that how we can control the superstructure on a soil by providing those aspects to our superstructure, specifically structural engineers. So the shear strength play the most important role. How it they depend on cohesive and cohesionless soil. We have discussed that in cohesive soil what parameter govern, and cohesionless soil what a parameter help us. We have discussed. Okay. Apart from that, we have also understood that the shear strength is the most important key factor in designing the foundation slopes and retaining wall and any of the geotechnical structure. We have interrelated the relation between the normal stress and the shear stress. We have developed concepts that at what section the soil actually gets filled when after what we have taken the concepts of the parent body and detached body. We have discussed this many times, and we will also discuss again and again wherever it's needed, because it is the basic concept from which we are going along. Okay. So I think these things are very understood by you. So I am going in a very faster way. So this is a revision session for only 10 minutes. Afterward, we will go with new section. We have seen that actually the stress is acting in the triaxial direction, but we will generalize in the two-dimensional cases, and we have discussed those cases. We have interrelated the value of, if we know the two normal stresses, how we can in a two perpendicular direction, if we know the stresses, how we can find the stresses in at respective angle, at any angle from those two sections is given with in this interrelation. We have understood the Mohr circle, how the Mohr circle will help, how the center of Mohr circle is found, how the radius of Mohr circle is found, and what are the parameters that govern the value of the Mohr circle, that either the Mohr circle may say totally rightward or totally leftward. We have also taken the cases when the points Mohr circle get formed. So those characteristics are discussed during our initial two sessions only. We have understood how Mohr circle get formed, how the sign conventions works, and how the simplified solution can be developed on the basis of the complex parameters which is actually present in the soil. So we have generalized the solutions. We have developed. We have shown you the Mohr circle analysis, the center of the Mohr circle. What are the parameters? If we have known sigma x, sigma z, or sigma 1, sigma 3, we can find the center of the Mohr circle. On the basis of that, we can find the radius of the Mohr circle and respectively major and minor principal stress. We have developed a relation for the major and minor principal stress, which is given as below over here, and with the help of that we find the major and minor principal stress, and with the help of that we can form the Mohr circle. We can generate the radius, and on the basis of that we can also say that on the respective angle from this state of stress, what is the value of normal stress and the shear stress, and what would be the given angle is also stated with the help of the equations tan 2 theta equal to 2 tau by sigma x minus sigma z. And we have solved these problems. I think these problems must you have solved at this point of time. So I will not take the problem in any case. But and we have understood the value that when the passive and active state get developed in our study. In the pole is that point which Mohr circle, through which Mohr circle all the plane will pass. We have discussed this concept as well. Afterward, we have tried to generalize our case. So how we are generalizing is also equally important. The generalization means we have developed the analytical as well as the graphical method. When I am saying analytical method, so you need to understood that what I mean by analytical method. Sometimes my video might get off due to some reason, I think, because I can see on my other app. So if it remain closed for a long time, you can tell me. Otherwise, there is no problem. Sometimes network glitch can take place. Okay, I will go ahead. So generalized state of stress, when I say that the generalized state of stress, so what I mean by the generalization of state of stress? So basically on the basis of what we have developed the interrelation to find the shear and normal stress, we have only generalize the relation. If we know the stress in the two perpendicular directions, we can able to find the value of stresses at any angle from that section, and we can also find the value of the plane on which maximum shear stress get act, or what is the plane on which different type of, like when we solve this problem, we have solved this problem in the very first class. During this problem solving, we come to understand that how the value of stress at any other inclination can found. And when we solve this problem with the help of Mohr circle, with the help of the analytical approach, we have found that the sum of the stresses in the two perpendicular directions, when found at the other plane, remain constant. Like the value of sigma p1 plus sigma p3 is equal to value of 150. So here the sigma z plus sigma x is equal to 150, and sigma p1 plus sigma p3 is also 150. So these concepts, why this is happening, we have discussed and we have understood in a very good way. We have solved the same problem with the help of Mohr circle. I have discussed in very detail in the first class. You can go across those problems if you haven't seen it. Afterward, we have understood that shear strength is the function of sigma, and when we say sigma, sigma is the stress, and we normally take the effective stress because we consider the effect of the water. Afterward, we have drawn this diagram. We have discussed this, like the intercept on the y-axis is the value of cohesion, and the angle which made with the x-axis is the value of angle of internal friction, and on the basis of that, S equal to C plus sigma dash tan phi is our shear strength of soil, and this is the strength. And if the stress, the applied stress goes beyond that, it will lead to the failure of our soil sections. And Due to this only the failure takes place. So I think up to this point the concept is clear. So I will now discuss the second sections up to extent. Afterward I will go with the very new content which I have to take today, in which we are going to solve at least 14 to 15 problems. Okay, I think so the presentation is visible. Yes, yes, it is visible. Okay, let's go. Okay, so you can see that the we have explored the tri-axle testing. Beyond before that, what we have discussed, I will tell you. I haven't keep those points in the presentation for today, but I will tell you orally. So those who are new, those will be aware. We have studied the direct shear test, that is the box shear test. We have also taken the name of the different tests which could be performed to find the shear strength, but the major, mostly we are doing the direct shear test, vein shear test, and the triaxial test only. So this concern you need to understood like what will be the value variations when we perform the direct shear test, triaxial test, or the vein shear test. So we have understood that in the direct shear test the failure place is predefined. We already know that the failure takes place from this section only, so there is no control over there. In that case, with the pore water pressure measurement is also not takes place. We couldn't control those aspects, that either the water condition in a soil could be controlled by us in any way. So those problems are there. So in the specifically when we are performing the triaxial test, those problems get eliminated. When we talk about the vein shear test, the vein shear test is a test in which we inserted our Hence, your apparatus in the soil, we apply a torque to that. On the basis of that, we develop interrelations. There is a relation get developed through which we could calculate the value of the strength, and with the help of that, we are also able to calculate the sensitivity of soil that is given by the in the remolded section, undisturbed section by remolded section, we can able to find the sensitivity as well. UCS are undisturbed by UCS remolded, basically. The basic concept is that. So, and afterward, we have studied the triaxial test. So, in the triaxial test, what we are performing the test to find the weakest plane. Basically, we know that from the weakest plane, our soil gets filled. This is understood from the very first class, and I have discussed this again and again because this is the basic concept. So the earthquake can lead to the failures of soil, and some other factors like the slope instability and the other construction activity also lead to the failures. We have a very good understanding of the application and significance of these facts. Afterward, the Coulomb failure criteria we have discussed. So when we are talking about the Moore Coulomb failure criteria, we have discussed this cut. And today only, when we take the example, we understood like when we solve the problem specifically, we understood that as the value of sigma 3 get increased, the value of sigma 1 get also changed in that aspects, and on the basis of that there when a tangent is drawn to all the circles which get formed, we are able to find like the failure takes place from this section only. So this will lead to the generalization in a way. When I say generalization, what does this mean? This means the only one thing, and that very point is like the that common tangent is the result of the tangent to the all the Mohr circles. So the stress below that point will be called to be the safe stress on that the soil doesn't get filled. But if the stress get increased from this that envelop stress, so our soil must get filled in those cases. So we need to understand. We have discussed this in very detail. Some more points we have also taken about the Mohr Coulomb failure criteria, like it is a 3D simulations, it is actual representation. When we perform the test, we actually show what is really happening in a field, the stress, how stress get acts from the three directions we have taken, and apart from that, we also found that the stress which are acted in the field could be could be simulated in a could be simulated in a laboratory in one way or the other. So those understandings get understood with the help of this test. And how the apparatus is used, how the stress get applied, this apparatus presentation, how the cell pressure get closed. We perform the different type of, specifically three type of test like UU, CU and CD test. How this takes place and what are the setups we have understood in a very good manner. There are the two stages of the triaxial test. The first stage is the triaxial basically confining stage in which the cell pressure is applied, and the second stage when the axial stress is applied, like that is nothing but the deviatoric stress only. Okay, I think so. Up to this, the every point is clear, very clear. So we have when we say the confining state, the symmetry diagram show that section as well in which the stress is applied equally from the all the two perpendicular directions, and afterward when because in a triaxial test we are taking only sigma 1 and sigma 3 only. So in the third direction the value of stress is nothing but the stress get increased. First of all, sigma 3 is applied all across our sample, and afterward, the in a third direction stress get increased. When the third direction stress get increased, the value of sigma 1 each get found when the soil get fills. So we are able to draw the attentions, we are able to draw the Mohr circle with the help of sigma 1 and sigma 3, because when we get the value of the sigma d is nothing but sigma 1 minus sigma 3. So this is the apparatus which is already shown as well. What are the purpose? CD, CU, UU and UCS test we have discussed in a very good manner during our previous session. So we are able to find the cohesion and angle of internal friction. We are also able to find the value of basically cohesion and angle of internal friction is the shear strength parameters. With the help of that, we are able to state the property of soil. With the help of that, we are able to state the strength of the soil in a real sense. Afterwards, we have studied the advanced insights in the triaxial testing, in which we have understood like the different types of fluid which could be used in a confining state. We have also understood that how the load could be applied, and apart from that the length to dia ratio of the sample is also taken care of during our discussion. So and the correction, different corrections which are applied, like the AC equal to A by 1 minus delta L by L epsilon L, specifically we have discussed in a very good manner during our previous class. So those points you get very easily if you are there during that session. If not, if you have watched in the YouTube, then also you got it. But apart from that, in this fast manner, you might miss those points, because we have taken a very good discussion of approximately 15 minutes on that only during the last session. Because that is the most important case. The correction is applied. If you perform the that test in the laboratory as well, you have to be aware about the corrections. If you doesn't apply the corrections, the value you get it will be slightly different from what it should be. Okay, I think so. Afterward, we have understood that the total stress parameter and effective stress parameter, how the total stress parameter act in the UU test, because the in a confining and the stage 1 and stage 2 both cases, the valves get closed and the water is not allowed to pass, and the change in volume remain zero during this test. We have understood during the session. Apart from that, we have understood that when we are performing the effective stress approach, then the value of C and phi for all the cases give the same result, but this is not the case when we are taking the total stress approach. So I think so up to that this point is very clear to you. That is the section which is written over here. And apart from that, we have also developed the relation. This relation we are going to use today to solve our problems. This is one of the most important relation. You must need to be remember this relation in order to solve the problem. And apart from that, the rest of the things is also used during the sessions. Now I will start with some of the sections which I really want to discuss during this class. So I will now share this slide and I will go with a new content because the time is going beyond. So I couldn't go to the entire content. I think up to that point will be sufficient for your understanding of the today's session. Okay, so I am coming with a new content for today. Okay, my slide is visible. Yes, visible. I am able to see. As I have also joined with another account for my convenience that everything happening in a good way. I could also understood. Okay. So now I will start the this content for you in which we are going to discuss the specifically the today prime concern is to solving the problem. Today we are focusing on solving the problem, and before that we will take a small theoretical session as well, in which we discuss the theory, we discuss the Skempton parameter, like how the Skempton parameter could be used, because we already discussed as well during the last class the value of A and B, that those are the Skempton parameter. Okay, so give me a minute, I will take some water. Okay, so we will start from here with this session in which some of the very good concepts and good content I will be discussing with you. And one more request from my side. So please go by my side and must go at the last of the session. Over there, I give some of the homework for you. That is completely up to you. If you are doing, you must get benefited up to a larger extent. If you are not doing those, so whatever you learn over here, those implementations problems are written over here there. So please go through those problems at least once, so you will get the better idea of the system. Okay. So now we are discussing the first of all the interpretation of the triaxial result in the geotechnical engineering. We have understood the triaxial test, but how we can use the results which are found during those tests in the practical life, in which we are using our concepts, in which we are going with those aspects, those things we are now taking in our discussion. Okay. So I have divided it into several sections. I will take one section. Afterwards, there is a summary recap will be given there. Then I go with section. So with the help of section by section, now it will give you the better understanding. That's why I have framed in that way. And because when you go through my presentations after the class as well, it will help you in the same manner. I want to convey like if someone doesn't have attended my sessions and if he have presentation, he could get something. He doesn't feel like I haven't attended the session, so with the help of presentation also I am not able to get it. So that my basic concept, like whatever I am teaching you, if you attend the session you get 100%, and if you are not able to attend the session, if you are going through the presentation only, then also you must understand 60 to 70% thing, and that's my intention. Okay, so first of all, the triaxial test. So during this presentation, we discuss the interpretation of triaxial result. As I have already said, the result which is found, how to solve the problem with the help of those results we are discussing during this session. In a geotechnical engineering, how this takes place. Triaxial test basically we have already studied. Triaxial test is the commonly used to access the property behavior of soil. This is said commonly used, but when you go in the practical implementation, this test is performed widely, but this test is also costly. This over here we can control the pore water pressure. We can find how much pore water pressure get developed during the different UU, and CD test. Still, the practical field engineer sometimes prefer the direct shear test or the vein shear test, irrespective of this, because sometimes some of these tests are more time taking, and performing this test is not the easy for everyone. The specialist, the person who are good in that sections must be there in order to solve the in order to perform this test to a great accuracy, because accuracy is very important during this test. There are the several parameters we need to be accessed, and the person who are not aware about this test, who haven't experienced in these sections, may perform the test and give some wrong result. So that's why there some times the site engineers prefer some other test over this as well. But this is also one of the widely used tests in a field of civil engineering. Now, in our journey through the geotechnical engineering, we deliver the analysis of the compaction fill material using the triaxial test, the exploration, shed light on the critical interaction between the compaction, shear strength, and the material behavior. During the last class, you have must aware that we have taken the material behavior very seriously. That how the sorry, actually I'm suffering from little bit cold, so due to which some interventions takes place in mid between. Okay, okay. So over here. Uh, what I am speaking. Okay, okay. I during the last session, you must have aware that in the last session we have discussed about the material behavior characteristics which we are able to find during the testing of the triaxial test. So those sections we are primarily focused during the session. Then we come to the purpose. From the starting class only, the purpose and application is one of the important aspects. Whenever we have discussed anything afterwards, we have said that what is the purpose to do this. After that, we have asked the question to ourselves only, that what is the how we can apply this in the field in day-to-day lives, in the civil engineering, defense civil engineering works. So those things are also one of the most important aspects. So the triaxial testing is primarily conducted to identify the any issue or anomalies in the soil. So to validate the effectiveness of the compaction effort by measuring the pore water pressure. We, as already said, the pore water pressure is easily able to we are easily able to measure the pore water pressure during the triaxial testing. So the understanding the soil behavior could be found in a better manner, and the material characterization we are also able to find it also spoke out during the previous sessions, and how we are able to found is also taken into account. So the information which we found is the crucial for ensuring the stability and safety of the structure built on or with the soil. So this is the one of the important purpose. After that, we when we say the pore water pressure measured during the triaxial testing can help to in determining the nature of the soil and its response to stress. So, if the positive pore water pressure is there, it indicates that the soil is in the undrained condition, while the negative pore water pressure suggests the drained condition. So, by analyzing the pore water pressure, engineers can classify the soil as either the normal consolidation (NC) or the over consolidated (OC), which influences its shear strength and the deformation characteristics. Okay, so the Mohr Coulomb envelope, the result obtained from the triaxial testing, can be used to develop the Mohr Coulomb envelope. It is not used, can be used, not. It is mostly used. We have developed the Mohr Coulomb envelope during our, I think so, third or fourth class. We have developed the Mohr Coulomb envelope where we have stated like the value of sigma 3. First of all we have stated the value of sigma 3, and on the basis of sigma 3 we found the value of the deviatric stress. Afterward, with the help of deviatric stress, we are able to find the value of sigma 1, and on the basis of that we are able to find the Mohr circle radius and the coordinate on the x axis, basically sigma axis. So with the help of that, afterwards changing the value of sigma 3 to the second value, we are able to found with the able to when we set the value of sigma 3 to the second point, the value of sigma 1 also get changed. As when we discuss the total stress parameter, you must be aware that when we are discussing the total stress parameter, over there you have seen like the horizontal line get developed when we draw a common tangent. So why that case takes place? Because in that case the total stress approach is taken care. So the value of sigma 3 is given on the basis of that sigma 1 is found. The difference between sigma 3 and sigma 1 remains same when we change the value of sigma 3 to sigma 3 dash, the value of sigma 1 to sigma 1 dash change in the same proportion so that the radius of the Mohr circle remains same. So the tangent which is drawn over there is came out parallel to the horizontal axis, resulting in the value of cohesion only. No frictions, angle of internal friction got found during that test, and we are widely aware that the UU test is performed to find the behavior of the cohesive soil to a greater extent, because in that cases we assume we can say that water doesn't pass out because it takes lots of time in dissipating the pore water from the clay soil. So we take the UU test to perform the sorry, we take UU test to perform the to find the characteristics of the clay soil in a real extent. So by plotting the stress data from the different specimen on a graph, engineer can determine the coherency and the angle of internal friction of the soil, and this information is crucial for designing the stable foundation, embankment and other geotechnical structures. So these points become very important. Now we talk about economic consideration. We have studied the purpose, application, significance, everything we have taken. But economy is also one of the great aspects if you talk about the country like India. So we must be aware about those facts, like the economic consideration is one of the good aspects which we should be aware about. If we aren't, so we make our structure more costlier, and the country like us which are the developing in nature, we have achieved so much feat in the field of science and space. We have seen in the last month as well, but we must be aware about the economic consideration. When we see the example of Chandrayaan 3 only, that cost is only approximately 650 crores only. But when we compare that with the valuation which the different other countries are performing, they are spending too much, but we have achieved the same or more than those which is achieved by the other country by spending much less amount. So our achievement is also very brighter in nature, because we have achieved those feat in a economic way. And so the those aspects, as a civil engineer, as a geotechnical engineer, we should be aware to if whatever we are performing, economic consideration also need to be taken care of, because if the economic consideration doesn't permit, we are not going to perform those tests or those applications. We are not going to implement those things, because economy is one of the most important consideration when we are talking about the some of the projects which are of the great concern, like which are related to the institutional building or some of the most important buildings. So over there, we might think, okay, the cost is not the most important factor. We have to develop those sections in a good way only. We are not concerned about the cost. But in day-to-day life, day-to-day constructions, everyone is concerned about the economy. So economic consideration is one of the most important aspects. So why it is important, I will tell you. So it is important to consider the economic aspects of the geotechnical engineering project, and the process of filling and compacting soil involves significant cost, as it requires the excavation, crushing, and the compaction of the soil material. Therefore, engineers must be carefully analyze the test result and optimize the construction process to ensure the cost effective potential and risk. So I have already said the key. Cost effectiveness is the most important aspect if we are performing any of the test or any of the applications which is already get developed in a field, because we have to understand like which type of test and which type of consideration taken care in the different conditions to achieve our result. Okay, so the economic consideration is that only. Those points are written again. So I will recap this session for you. So interpreting a triaxial test result is a critical aspect of the geotechnical engineering. Exactly, and by analyzing the pore water pressure, developing the Mohr circle, Mohr Coulomb envelope, considering the economic factors, we engineers can make decision regarding the sustainability, stability, suitability of the soil for the various construction projects which are going to develop on those sites with the help of the value of the strength, when we state the value of strength over there. So now we have already discussed the material properties, also one of the important aspects of our discussion. So the significance of the pore water pressure building upon the concept of pore water pressure to speculate the soil nature, bridge or to the triaxial testing, the transition to the another class of problem centered on the compacted fill material is also one of the important aspects when we say about the compaction and the soil characterization. So the reflection of method like the balloon, sand replacement, core cutter in situ determination. You must be aware about the core cutter method. So I will over here the core cutter method and sand replacement came. So I will tell you those process in a little faster way. I think you have performed those tests up to now, but I will tell you how we perform. So first of all, we take our core cutter, which is there is a dolly attached with that. We take the weight of the core cutter. After that, we take the core cutter to the field. Over there, we insert the core cutter into the field with the help of a hammer. The hammer weight is approximately 9 kg. Afterward, the section is removed from there, and the section is removed from there. And in the meanwhile, it has been found that the soil which came with that is taken to the lab, and the weight is taken over there. Afterward, we are able to find the bulk density because we already know the diameter and height of the core cutter apparatus. Afterwards, when the total weight and the total volume is known of the core cutter, we are able to find the bulk density, because the bulk density is the total weight by total volume. Afterward, we take the some sample from the middle of that soil layer for with us, and that soil layer is taken to the laboratory and kept in oven for 24 hours before, and we perform find the water content of that sample. Afterward, we are able to find the right density. Similarly, the sand replacement also takes place. So these are the tests which we perform to find the basic property of soil. Afterward, you must be aware about the Proctor test, like light compaction and light compaction and heavy compaction test, with which also we are able to find the optimum moisture content and the maximum dry density for the characterization of soil. So we can state that this type of soil has this characteristic. And if we are find the maximum dry density and the minimum dry density, or the maximum void ratio, minimum void ratio, so we are also able to state the value of the relative density, and the relative density state the property of soil in a broader aspect as compared to the void ratio. You must be aware about this fact from the basic of soil mechanics, mostly when we say the geotechnical engineering one. Now, understanding the relationship between the deformation and stress on the dry and wet side is also understood. The shear strength is come under the shear strength interpretation, and developing the holistic approach to involve the particle size distribution, compaction curve, compressibility, and the triaxial test. Because we you know with the help of these tests we are able to find those properties. Now I will state some of the example. Okay, okay, give me a minute. Okay. So over here now we are taking some of the example, the practical example in which we are stating like what how we change the value of sigma 3. Suppose when there is a test we perform, we change the value of sigma 3 from 150 and progressively increasing by 50 difference to up to 450. Similarly, the value of sigma 1 also gets changed from 400 to 1000 in the same concern. And how this gets changed when we say about the tri-axial testing, this get changed in a proportionate way depending upon the type of soil and depending upon the type of test. If the sigma 3 value is 150, on that if the sigma 1 is get 400, so the diabatic stress must be there 250. So we perform the value of apply the value of sigma 3. After that, the diabatic stress get applied from top and bottom, as it is shown in today lecture as well in starting. Over there, I have shown you how the value of sigma 1 got found, and when we found the value of diabatic stress, so we can state the value of sigma uh, value of sigma 1 as 400. So if the value of sigma 1 is 400, so the and sigma 3 is 150, so the dividend stress must be applied 250. Afterward, we have increased the stress to 200, sigma 3 is value to 200. For that also we are able to find the value of some sigma 1 value. Similarly, when we go section by section up to 450, suppose when we apply the sigma 3 value of 450, we are able to find the value of sigma 1 as 1000. So this is also understood like if we are seeing the sigma 3 is 450 and sigma 1 is 1000, so what should be the value of deviating stress is also the one of the question when you get to go to the very basic examination. So over there in a short one number question, this is asked the value of sigma 3 is this and the sigma 1 is 1000. So what is the value of sigma 3? So this is the question for you as well, but over here I will state the answer for you. Like the value of sigma 1 is 1000 and sigma 3 is 450, so the value of deviating stress is 550 because sigma d is nothing but sigma 1 minus sigma 3. But when we actually perform this test in the field, we are not able to find the value of sigma 1 directly. We are able to find the value of sigma d on the basis of value of sigma 3, which is 450. So we can state that the value of deviating stress is nothing but 550. Basically, we are able to find the value of deviating stress as 550, and on the basis of that, we can state the value of sigma 1 as 1000. So, on the basis of that, we have also the interrelation between the sigma 1 and sigma 3 as sigma 1 equal to sigma 3 times for 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. So, with those interrelation when the sigma 1 and sigma 3 is known, and if we know the soil is the cohesive soil, then we can consider the value of C only phi as 0, and on the basis of that, we can state the value of cohesion. We are going to solve the problem like those today only. Or might be I will take some more question in the next class, but today we are going to solve at least 13 to 14 problem, maybe 15 problem. Whatever the time permit, I will take all the question. Maybe I will shorten the theoretical part, leave it to earlier extent, and I will take the problem first because those problems help you more than whatever theory part I am discussing right now. Because these things you can understood very easily. Okay. So now the interpreting the result. Okay, we are talking about we have to interpret the result whatever the value we are getting. So the effective stress changes we have to state that how the value of stress gets changed. So those consideration must need to be understood. Now I am coming to the next fact like un undrained and drained parameters. So when we are talking about the undrained parameter, though when the drainage is not allowed, the parameter is called the total stress parameter, total shear stress parameter. But when the drainage is allowed, the parameter which we are able to find is called to be effective stress parameter. Okay, I think so that is very clear to you from the earlier discussion as well. So the journey from the soil compaction to the shear strength analysis explanatory the different layers of its open the different layers of geotechnical engineering for the understanding and by skillfully combining the laboratory test and the field knowledge. We take the soil sample and perform the test in the laboratory, but when we combine the laboratory test and the field knowledge, the engineers can unlock insights the crucial for the safety, safe and effective exploitation of soil related project, because any project which are sustained on the this universe are created on the soil only. So that aspects need to be understood by the civil engineers before going to designing the superstructure for us. Okay, so over here I will take a 5 minute break. We will start at 4:43, uh, and we will go with our session. We have to go little quicker in our second session after the 5 minute break, because we have so much content with us. Okay, so I will take the 5 minute break over here. I will start at 4:02 or 4:03. Welcome back. Now we will go ahead. Okay, so first of all, the decoding the soil behavior through the shear strength analysis. We are taking that session. Now we are going very fast for some time because we have to reach up to our problem because the prime concern for today is to taking those problems only. Because so I will keep at least 45 minutes for the problems. If time doesn't get permit, it may get extended uh, for at least 5 to 10 minutes. But I will try to cover the entire content within the given time only. Okay. So first of all, the further in the geotechnical engineering, we explore the different relationship for the compaction shear strength for water pressure in a different type of soils like clay soil, cohesive soil, and cohesive soil. These presentations give the insights into the how the undrained test specifically CU test reveal the crucial information or the interrelation. You must be aware about the compaction test, which you must be performed during your lab test. You must perform UCS test. Ah, I have a little cough, so I'm sneezing in between sometime. That's why I close the audio and video in sometime for a minute. Okay, so please excuse me for that. Okay, I will go ahead. with this only. So we are understanding the long term and short term stability. Okay, we will start in 1 minute. Okay. So, differentiating the drain and undrained test, the long-term stability access through the drain test, while the short-term stability is exploited via the undrained test. We have understood about the drained and undrained test. So, when we are saying undrained test, what we are talking about? We are talking about UU test. In UU test, the valve is not allowed open in order to pass all the water through it. So that test is said to be undrained test. But when you are talking about the drain test, which test is drain test? You must be aware, you must be understood whenever you go through the lectures of sir or might be mine. I have discussed again and again that about the factors of the drain test. So in drain test, the valves remain open for both the cases, and that test is CD test. But one of the most important aspects we must need to be understood. And what is that aspect? Like in UU test, UU test the valve remain closed, so it is the fastest test. But when we take the CV test, it is the one of the slowest test because it takes lots of time, lots and lots of time to get the test result to be developed. And we also apply the stress in a very slow manner in order to it doesn't get transformed into pore water pressure. The stress is applied very slowly during the CV test. So the drained and undrained parameter are equally important when we are performing our test. Now the material nature, exploring the dual nature of material, cohesive and the frictional, and its implementation is equally important when we are talking about the long term and short term stability. Now when we say CU test on soft soil. So when we analyze the CU test conducted on a soft clay sample, promoting a question about its nature and the necessity for triaxial testing. Okay. From starting only, we have always talked about the significance, application, purpose. So over here as well, when we perform any test, like we have already said, we are performing U test for the clay soil. Over there we are able to find the total stress parameter because the pore water pressure is not allowed to dissipate in any way. But is it the case over there the effective stress parameter could be found? Yes, surely, because we doesn't allow the water to flow out, but we can measure the pore water pressure in that case as well. Okay. Now, over here we are talking about the CU test. The CU test is conducted on the soft clay sample, prompting question about its nature and necessity for the trial testing. Overcoming the softness, addressing the challenges posed by the soft and sensitive clay sample through the unconventional testing methods unconsolidated undrained test like UU test, which I am currently discussing, and the Valencia setup. We have discussed about the Valencia test setup, and on that setup, when we are discussing about that test, we have already said that this test could be performed in the soft soil. Otherwise, we couldn't able to apply the torque. Because in the Valencia test, the torque is the most important parameter. If we doesn't able to apply the torque, we doesn't able to sustain the result, we doesn't able to explain what the value we are getting from our testing. Okay. Now, extracting the shear strength and parameters, when we are talking about, we are concerned about to finding the value of C dash and phi dash in a real sense. And when we talk about the C dash and phi dash with the effective stress condition, so the we must have some problem statement. So I will tell you problem statement as example. Not we are solving the problem at this point of time. We are solving the problem today only. So we are running out of time. We are going very quick to the problem, and we take those problems first of all. After this section get over, we will go to the problem only. So the starting the problem of determining the pore water pressure in a soft clay specimen during the undrained testing at a field work. We have to be significant if we interpreting the problem, the highlighting the uniqueness First of all, we have to understand either the soil is a clay soil or sandy soil. If it is a soft clay, then we implement, like if we use the relation, our sigma 1 equal to sigma theta is for 45 by 45 plus 5 by 2 plus 2c and 45 plus 5 by 2. If the soil is clay soil, we consider the value of phi is 0. And similarly, if specifically if you are performing the UU test, we take the value of C only. If you are performing the CD test, we take the value of phi only. But when we are performing the CU test, depending upon the demand, what the value we are there and what we are needed to be find, we take those consideration accordingly, and this become very important while solving those problems. I will take some of the basic and advanced problem today on this topic, and two more problem is coming in our next class from this section only. If it is discussed in the next section, okay. Otherwise, I will must take the two more problems from this section, which is very good problem. Why I am not taking those two very advanced problem today? Because you might get confused today when we are studying the solution of that problem. But when you solve some more problems what we discussed today, we are able to develop the concepts, and afterward if I give that problem to you, you are easily able to state the answer to me in a no time. But that is the question is soon to you. You have to solve first of all. Afterward I will state the solution during the next class. In the starting of the next class, I will take those two problems. Now, the significance of the software. Okay, I have discussed this. NC and OC section is also discussed during the last session. The Mohr circle and its envelope criteria is also stated in a very good manner. Now, analyzing the stress condition and their relevance is also important. The stress condition, when you are talking about stress condition, it's become the total stress condition or effective stress condition. Basically, the result we stated, we okay. Am I audible? Some sounds is coming. Hello. Anyone microphone is on? Okay, give me a minute. I have to check. Okay. I think so. Anyone's microphone get opened? It's going now. The sound is. Hello. Hello. Am I audible? Give me a minute. Hello. I think so. I'm audible. Hello. Hello. I think so. The sound is clear. Sorry. I think so. Now everything is okay from my side. There might be some problem from my end. That's why some sounds is coming. I will again join with my another account so I can check the status what's going on during the meeting. I think so. I am audible. Yeah, I am clearly audible. Okay, okay. Now I will go ahead. The presentation is also visible. Okay, it is visible. Now I will go ahead. Okay. Okay, so I am discussing about the Mohr Coulomb Mohr circle and its envelope. So we have discussed this section. I have just kept you for the revision, but now at the time we are short of time, so we will go to the problem directly. Afterward, we can come to this section, but it doesn't matter because we have to main concern is to solving the problem. So during this section, we have illustrated the different sections, interpreting the material properties, test condition, laboratory methods, and under scores and the precision required for the geotechnical engineering analysis. So now we are coming to the problems. Afterward, we come to this section because I don't want to compromise for time for the questions which I have developed for you, which I have taken from different places. So that's become more important. Afterward, we will come to this if time get permitted. Or doesn't matter. These section, these things will be shared with you, so you can go through that afterward as well, and you can able to understood those things. Sorry, the cough is there. So little bit problem. Okay, so first of all, I will start with a very simple problem of true and false, and I will state the answer as well over here. If someone of you are interested, you can write the answer in the chat box. I will give you a reply. Okay. So slide is also visible. So the first question is the true false question. Over here, the question is if the Mohr circle for a given state of stress lies entirely below the Mohr envelope for a soil, then the soil will be unstable for that state of stress. So you must have the awareness about the fact that okay, I will draw this for you as well. Okay. You can see this is the section. This is the section. I think so. My drawing is visible to you. And the question is asking if the Mohr circle for the given state of space lies entirely below the Mohr envelope of the soil, then the soil will be unstable for that state of stress. Okay. So suppose the first of all Mohr circle get formed like this. Afterward, the this is the value of sigma 3. This is the value of sigma 3, and this is the value of sigma 1. And how we are getting, you have already understood. After that, the sigma 3 value is changed to sigma 3 dash, sigma 3 dash, and sigma 1 value also got changed to sigma 1 dash. Afterward, when we draw a common tangent, we found this type of straight line. Okay, I'm not able to draw the straight line, but you understood this is a straight line. Okay, everything so this thing is clear. I think so clear. Okay, so first of all, you see that this line representing Mohr Coulomb failure in Halo. So sorry. Okay. Okay. So this line is representing the Mohr Coulomb failure in Halo over here. I will draw this for you. This is Mohr. This is Mohr Coulomb failure in Halo. Okay. Mohr Coulomb Mohr column failure envelope. So the question over here is stating like if the Mohr circle for the given state of stress lies entirely below the Mohr envelope for a soil, then the soil will be unstable. But whatever we have studied, we studied the stress below the Mohr column failure envelope will remain in a stable state and the stress above or just at the Mohr Coulomb failure envelope will be in the unstable state. So the answer of this problem is going to be false. I think so. This thing is clear. Okay. Now you can see over here the answer stated is false. Is exactly what we have discussing. So it is written also explanation is also written over here. If the Mohr circle for the given state of stress lies entirely below the Mohr envelope for the soil, then the soil will be stable for that state of stress. And we have understood this with the help of this representation. Okay. Now the next question is the an unconfined compression test. An unconfined compression test yield a strength of 0.1 Newton per mm square if the failure plane is inclined at 50 degree to the horizontal. What is the value of shear strength parameter? So what this question is asking? This question is saying in a unconfined compression test yielding a strength of 0.1 Newton per mm square. So what is the value of 0.1 Newton per mm square? Okay, you need to understood this. If the failure plane inclined at 50 degree to the horizontal plane, then what will be the value of shear strength parameter? So basically, it is over here we have the value of shear strength. We have the value of phi. We have to state the we have the value of theta c, and we have to state the value of c. So I will again draw this section for you. I think so. I can draw over here. So over there, it is given the value of theta c is 50 degree. Theta c is 50 degree, and we know the interrelation as sigma 1 equal to sigma S equal to c plus sigma plus 2c tan phi. S equal to c plus S equal to sigma plus 2c tan phi. We already know. So in the case of unconfined compression test, when the value of sigma 3 is 0, the relation saying sigma 1 equal to sigma 3 tan square 45 plus phi by 2 plus 2c tan 45 plus phi by 2. Okay, so over here you can see that over here you can see like you can see the value of the sigma 1 equal to sigma 3 times for 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2 is written only, and in this case we are able to we have used the same interrelations and we have the value of theta c is nothing but 45 plus 5 by 2. So with the help of that we are able to find the value of phi, and you can see over here I will again draw with the pen for you. So you can see this is the value of interrelation of theta c equal to 45 plus 5 by 2. and with the help of this interrelation, we are able to find the value of phi, and with the help of that, when the value of phi is known to us, the value of shear strength is also known to us. That's equal to 2c tan 45 plus 5 by 2. When we use sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 by 2, this relation is when used over here, we are able to find the value of c as well. I think so. This point is clear for everyone. So we are able to find the shear strength parameter. When we say the shear strength parameter, what is the shear strength parameter? The shear strength parameter is nothing but the value of cohesion and angle of internal friction. So able to we are able to get the value of C, as well as we are able to get the value of C as well as pi in this section as C as 0.0419 Newton per mm square and pi as 10 degree. Okay, I think so. This much point is clear. Now the next question. The next question is the unconfined compressive strength of a stiff clay fall in the range of. So this is a question which is asked several times in the different examinations. So this concept need to be understood if you are preparing for any of the competitive exams. So these types of question is frequent and asked on a regular basis. So first of all, you can state the answer in a chat box. But okay, I will not take those that much time because I have to solve many problems. So I will state the answers for you. The answer for this problem is the value lies between 100 to 200 kilonewton per uh, meter square. This will be going to be answer. So how we can say the this is basically one of the memory based question as well. So you must need to be understood that some of the concepts need to be remembered as well for giving the answer of the problem during the examination. So, unconfined compressive strength of a stiff clay falls in the range of 100 to 200 kilonewton per meter square. Now, moving to the next problem. Over here, I have kept the two problems and the solution for the question number 5 and question number 4 and 5 is given on the next page. But first of all, we will read the question. I will state the question. I will explain the question, and afterward, I will show the solution for the given problem as well. So, first of all, the question is asking what is the shear strength? What is the shear strength in terms of effective stress on a plane within a saturated soil mass? The every point is equally important. At a point where the total normal stress is 295 kilopascal, pore water pressure is 120 kilopascal, the effective stress and the shear strength parameters C dash as 12 kilopascal and phi dash as 30 degree. So the C dash value is given, phi dash value is given. The question is asking about the shear strength in term of effective stress. So the effective shear strength parameter is also stated. The soil is said to be saturated soil mass and the total normal stress is given as 295 kilopascal and the pore water pressure is 120 kilopascal. So you have to understood if total stress is given, pore water pressure is given, you have to find the effective stress. In terms of effective stress, you have to subtract the value of 120 pore water pressure to get the effective parameter. So you can see the problem here, the sigma and value is 295 and u as 120 and c dash and phi dash as 30 this. So I already said you have to find the sigma effective, which is written as sigma n over here. So we have to subtract the value of 295. We have to subtract the value of 120 from 295. That is 120 is nothing but the pore water pressure, while the 295 is nothing but 295 is nothing but the value of 295 is the value of the total stress which is acting over there. So we have subtracted the pore water pressure from the total stress and we get the effective stress. And afterward, we have to find the shear strength. To find the shear strength, we have used the interrelation S equal to C plus sigma and tan phi or tau equal to C plus sigma and tan phi, and we are able to state the value of tau over here. Now I will move to the next problem, and next problem is about question 4 and question 5 is stated above, and question 4 and 5 solution is stated below. Sorry, I am taking now the question number 5 for you. Okay, so first of all, what the question number 5 is stating, we have to understand. So the question is here: in a drained triaxial compression test, a saturated specimen of cohesionless sand. So you have to first of all underline the important things. First important thing is drained triaxial compression test. Second is specimen is saturated specimen of the cohesionless soil. Cohesionless soil means phi term has something taken over there. The what will be the value of phi, and these things we need to be understood. Cohesionless soil. There is a no cohesion there means the value of C is zero. We could say cohesionless sand. Okay, cohesionless sand. ठीक, okay. So I think so. This point up to clear. Hence, under the deviatric stress of 3 kg per cm square, hence the value of sigma 3 is 3. Sigma 3 is 3. And the when the self, okay, sorry, sigma 3 is nothing, but this is sigma d. Eraser I have to take. This is sigma d, and sigma d nothing but sigma 1 minus sigma 3 is equal to 3. Okay, and when the cell pressure is 1 kg per cm square means value of sigma cell pressure means sigma 3. I think so these things is clear for everyone, because I have discussed too many times and I have stated too many times. If it is not clear, so you need to be work out on my last lecture. So the value of sigma 3 is known, sigma 1 minus sigma 3 is known, and sigma d is nothing but sigma 1 minus sigma 3. So now you can state very easily the value of the sigma 1 will be going to be 4. I think I need not to write over here. Over in the next page, it is also stated as well. So you can see that sigma 1 minus sigma 3 is the deviatric stress, and it is stated over here. The value as 3 kg per cm square. After that, we are able to find the value of sigma 1, which is 4. And after that, using the interrelation sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. And it is already stated. It is already stated the cohesionless sand. So due to this region, the C is equal to 0, and due to which we have taken this relation as this relation as sigma 1 equal to sigma 3 times per 45 by 2. Alpha is nothing but 45 plus 5 by 2. 45 plus 5 by 2. So we have solved these equations accordingly. We got the value of alpha as 63.43, but we are not interested in getting the value of alpha 45 plus 5 by 2. We are not interested. We are interested in getting the value of phi, because The question is asking about the effective angle of shearing resistance. The effective angle of shearing resistance is nothing but phi. Value of phi is asked in this problem. So we have to state that only. So with the solving, we get the value as 36.86, which is 37 only. So our answer of this problem is answer of this problem is A. I think this is clear for everyone. Now I will move to the next problem. Now the next problem is asking again. We have two problems: problem number 6 and problem number 7, and accordingly solution is also provided. So the question number 6 is there. It is asked in some of the examination which consists of the 2 mark question. But when it come in the normal examination, this might be 5 to 8 mark question, or maybe sometime 10 mark question. Some of the problems which are here, and as I stated earlier, I will take some specifically 2 questions during the next class, which are very good problems during the starting of the session. If so, please come after solving some of the problems from this topic, so you will be able to understood those things, and you are able to answer the problem earlier than during the class as well. So I hope you will come with that mindset. Sorry, the little cough is there, so that's why I'm not feeling very well during this season. But I think whatever I have stated, what I have a doubt during season is understood by you. Oh, I'm sorry for the inconvenience. Give me 1 minute. Hello. Okay. So I will go ahead. Actually, there is a problem related to cough. That's why I'm sneezing sometime. Okay. So the problem over here is the question number 6 for you. So in this question statement, it is written that if the effective shear stress strength parameter of a soil are, excuse me, C dash at 10 kilopascal and phi dash at 30 degree, and shear strength on a plane within the saturated soil mass at a point where the total normal stress is 300 kilopascal and pore water pressure is 150 kilopascal. Excuse me. Okay. So I will go with this problem first. So you can see, first of all, I already said, mention whenever you got the question, you underline the things which are there, so you can understood while solving the problem. The effective shear stress is a term used, because effective shear stress and total shear stress are different terms. If the total stress, the total stress shear strength parameter is known. If the effective stress is there, the effective stress parameter is known. So those things need to be understood by you. Okay, so over here, first of all, the value of C dash, effective shear stress is acting, and then effective shear stress parameter C dash and phi dash is given, and the shear strength of a plane within the saturated soil mass where the total normal stress, not the effective normal stress, total normal stress is given, and the pore water pressure is also mentioned over here. So the shear strength on a plane within the saturated soil mass at a point where the total normal stress and pore water pressure is given. So first of all, we will get the effective stress as 300 minus 150, and after that into tan phi we will do. So 150 tan 30 plus 10 is our going to be our answer. So you can see over here, we have did s equal to c plus sigma and tan phi. So over here you can see, I will write for you, so we'll get the better understanding. So c plus c dash, basically c dash plus sigma n minus u into tan phi dash and phi dash. We have did this. Afterward, we are getting the value of 96.6 kilopascal. This is a very simple problem. But if you are not too much concerned with this problem, you will mark the wrong answer and ultimately result in the reduction of your marks. So be aware about that. The what the question is asking. If the total normal stress is given, we have the shear strength parameter, total effective stress parameter. So those things you need to be very clear with in your mind. Now we will move on to our next problem. So next problem is the problem number 6. So what is in the problem number 6? You must need to be understood. So the over here the problem number problem number 7. In problem number 7, question is triaxial test is carried out on a cohesion-less soil sample with the cell pressure of 20 kilopascal. So I already state you. First of all, you have to underline the important thing. The first point to underline is the cohesion-less soil. Cohesion-less soil means C is equal to 0. Afterward, the cell pressure is 20 kilopascal. This means the value of sigma 3 is going to be 20. Okay. After that, the statement is the observed value of applied stress at the point of failure is 40 kilopascal. Applied stress at the point of failure is 40 kilopascal. So it is asking about the angle of internal friction. So you need to be understood the value of 40. What is this? 40 is nothing but deviatoric stress. 40. So you already say the value of sigma 1 h, sigma d equal to sigma 1 minus sigma 3. So the value of sigma 1 is going to be 60. Okay. So the angle of internal friction is asked. So we will solve this problem over here. We can solve this problem over here only. Otherwise, I can show you with the next slide over there. The question is already solved. But you must understood. Now we apply our basic equation as sigma 1 equal to sigma 3 times for 45 by plus 5 by 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2, and we can state our answer the value of phi, which is asked. The question asked is angle of internal friction. Angle of internal friction is asked. Question is asked like the value of phi is going to be what? This is the problem. This is the questions which is asked by the examiner. So we will answer this problem. Okay. So you can see In the question number 7, the first of all, the value of sigma 1 is calculated as 60, which we already calculated as 60. After that, the interrelation is used sigma 1 equal to sigma 3 times square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Using this interrelation, the c is 0. We already mentioned c as 0. Afterward, we are able to find the value of phi as 30 degree, and this is nothing but our answer. So our answer is 30 degree. So option D is correct. I think so. Up to this point is very clear. Now I will move to the next problem. The next problem is related to the saturated cohesionless soil. Again, the soil is cohesionless, so the C value is 0. Saturated cohesionless soil. So first of all, you have seen this. You have to write cohesionless, then C is 0. After that, then is tested in a drained triaxial compression test. Drained triaxial means value of the value of C dash and phi dash is obtained because the condition is drained. Drain means effective, effective stress. Okay, I think so. My handwriting might not be very good because I am writing with the help of mouse. So C dash and phi dash C equal to 0, C dash and phi. So the effective stress value would be there, and the value of uh, the value of the dielectric stress at the failure of the sample at the confining is 200 kilopascal. So the value of sigma 3 no, no. The dielectric stress at the failure of the sample, dielectric stress push is, it is asking the dielectric stress when the confining pressure is given as uh, confining stress is given as 200. So we have to use the interrelation sigma 1 equal to sigma 3 times square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Sorry. So with the help of that interrelation, we are able to find the value of sigma 1, and we have used that interrelation. We find the value of sigma 1, and we have to find the value of sigma 1 minus sigma 3 as deviating stress. So we are able to find our solution. So 400 kilopascal is our answer. I think up to this point, the concept is very clear. Okay. So now I will move to the next problem. So what is the next problem over here? So you can see in a next question, it is a direct shear test was conducted. So direct shear test is nothing but the box shear test. Yeah, up to this time, I think you are very well aware about this fact. The direct shear test is nothing but the direct shear test is nothing but the box shear test, which we have discussed at the several occasions. Okay. So then a direct shear test was conducted on a cohesionless soil where C is equal to 0 and C is equal to 0 it is given. And another point is mentioned the specimen under the normal stress sigma n is given 100. The specimen fell under at a shear stress of 100 kilonewton per meter square. Sorry. So the angle of internal friction is asked. The value of S is given, value of C is given, value of phi need to be found, and a value of angle of internal friction need to be found. So the question is phi, hmm, and everything else is given. So we apply the basic equation as S equal to C plus sigma tan phi, and we apply the equation as S equal to C plus sigma and phi. Okay, and the this value is 0, and under the normal stress of 200, so this value is 200, and S value is 100. So we find the value of phi. When we solve this, we get the value of phi as 26.6 degree. So this is the correct answer. I think so. This is very simple problem of the direct shear test. I also take one problem of the base shear test for you. So up to this point is very clear. So that is done over here as well. So no need to again go for that because I already solved that for you. Now the next problem is here. This problem asks a soil is composed of a solid spherical grains of the specific gravity and the diameter between 0.075 to 0.0075. If the terminal velocity of the particle falling through the water without flotation is 0.5 mm per second, and so the for the smallest particle we have to find. Okay, this concept we haven't discussed, but this question I have given, so I will state you the concept behind it. You must have understood that the setting velocity. If you have read the environment, there is a setting velocity is there. Over there, the setting velocity is proportional to d square. The velocity is proportional to d square. Okay, because there is interrelation as I will write v is equal to um, g minus 1 into rho into g into d square by 18 mu. Okay, sorry. So this relation is there, and while using this relation, we can see that v is proportional to d square. So when we in this problem, it has been stated the terminal velocity for the largest particle falling through the water without flotation is 0.5 mm per second. So the largest particle over here is 0.075, and we have to find the velocity of the smallest particle, that is 0.0074. Okay, I think up to this point everything is clear. So this is a very simple problem. When you solve as v is proportional to d square, and when you state this equation, you are able to get the value as 0.005. So our answer is nothing but A. I think so. This point is clear to you. This is equations you need not to remember when we talk about the soil, but in this problem also interrelate to the concept of soil as well as geotechnical engineering as well, because as per Stokes law this is taking place. Over here it is written as well according to Stokes. Okay. Now we have a problem related to Veil shear test. We have read the Veil shear test in a half of the basically in 1 hour we have discussed the Veil shear test. We have discussed the apparatus. We have discussed the test. We have discussed the interrelations. So over here there is a need. If we have discussed, we have spent that much time, so we must need to be aware about this test as well. So for in that regard, I have given the problem for that section. So you can see, first of all, I will read the problem, then I will solve this problem for you. Or So the first of all, this problem is a field shear test instrument soon along was inserted completely into the deposit of soft saturated silty clay with the vein rod vertical such that the top of the blades were 500 below the ground surface. Upon application of the rapidly increased torque about the vein rod, the soil was found hale when the torque reached to 4.6 Newton meter. Assuming the mobilization undrained shear and the resistance mobilization on the surface of the vein rod to be negligible, what will be the peak undrained shear strength round off to the nearest integer. So first of all, the value of torque is given as 4.6 Newton meter, and I will state the interrelation for not as T by pi d square into h by 2 plus d by 6. This is the value of shear strength. Okay. So over here T is given. T is given as 4.6. Okay, and H is given as D is given as 50 and H is given as 100. Okay, so when you apply this interrelation, you are able to find the value of S. So that's only we need to do. Other things like 15 mm and rest of the things are not relevant for us. So we have applied those interrelation. Uh, you can apply that relation and we are able to find the value of S and UCS by 2 is the value of cohesion. We are able to find the value of CH 10 kilo Pascal. D by pi d square into h by 2 plus d by 6 is only. And with the help of that, we are able to find the value of cohesion. So our answer is going to be 10. Okay. Moving ahead, we will move toward our some of the more problems. So this is a problem, and the answer is already stated. So I will explain this only for you. The question is there. So the question is here: the for a saturated cohesive soil, um, triaxial test yield the angle of internal traction phi as 0. The conducted test will be the value of phi is 0. So it is already clear the soil is a cohesive soil. So we need to understood if the soil is cohesive, then we perform the UU test for our study. So our answer is option number D, that is the unconsolidated undrained test, because it is discussed at the several occasions that the UU test is performed for the cohesion, basically cohesive soil. So here the internal friction is zero, so the soil is cohesive. So you test is performed. But similarly, in the CD test we are talking about, that is we are talking about the soil like sand. This total stress approach, effective stress approach work accordingly as well. Now we are moved to our next problem. We are moving to the end of our session because we have two more problems with us up to that. Afterward, we will close the session. So, in an unconsolidated undrained test, it is observed that the increase in the self pressure from value of 150 to 250 kilopascal lead to the pore water pressure increase of 80 kilopascal. It is further observed that increase in of 50 kilopascal In diabatic stress result in the increase of ethanol kilopascal in the pore water. These are the Skempton parameter B is asking. So we know the value of B is delta U by delta sigma 3. So answer is like 80 divided by 250 minus 150. So answer is C 0.8. I think so. This is clear. This is very clear. Okay. So we will move ahead. Same thing is solved as well over here. Uh, After that, the question we are interested in the drained triaxial compression test on a saturated clay yield the effective stress strength C dash as 15 and phi dash as P dash as 15 kilopascal and phi dash as 22 degree. We consolidated and then triaxial test of the identical sample of the clay. The cell pressure is 200 kilopascal developed and the pore water pressure is 150 at failure. The deviatic stress it is asking here. So time is less. I will show from the solution. I will not solve over here. You can see we have the value of sigma 3 200, U is 150, and sigma 3 bar this is very effective. Sigma 3 minus U is 50 kilopascal, and the effective shear parameter C dash and phi dash is also stated as 15 and 22 degree. So we use that value and we find the value of sigma 1 as this. And when we subtract sigma 1 bar minus sigma 3 bar, we get the value of sigma B as 104. So this is the solution of this problem. Moving ahead for the last problem of the day, the question is soil sample is subjected to the hydrostatic pressure sigma. Hydrostatic pressure sigma means the stress applied from the all direction is same. So I will show you like this. If it is in the two dimension, with the stress applied is like this hydrostatic pressure is like this, or maybe you can take if you take other way, it's maybe like this. But when it is water, it is always involved only. But I will explain with this image hydrostatic, not the see thing which is acting over here. So the Mohr circle at any point would be. So when we solve this with the help of Mohr circle, the point Mohr circle at a sigma distance from the origin. So the answer is C only. Okay, as it is shown, it is not always the case. It is rightward only. It may be leftward as well. Okay, so with this, there is one more problem. Okay. Okay, no problem. So the one more problem is consolidated undrained test is performed, and while performing we find value of sigma 3 as 100, and finding pressure is sigma 3, and the diabatic stress at failure is this is sigma 1 minus sigma 3. Okay, and the pore water pressure measured at failure is 50 kilopascal. So this is U. The effective angle of internal friction we have to find. So no problem. The compression test is conducted normally considered a confining pressure. Everything is given. So we will just put the value of sigma 1, sigma 3, and sigma 1 minus sigma u. And after that, we will find the value of phi dash at 26.4 degree. This is the solution of this problem. So we are running out of time. What we have understood today, the problem on UU, CU, CD test, basically triaxial test problem, ratio test problem as well, which is not mentioned here. And apart from the direct shear test problem, I already discussed today. Apart from that, these are some of the problems you will answer. And one most important homework is solve the problem which I have discussed today in a class. with yourself, with your hand, with your mind, you will get a very good idea. The solution is already there, and I also write some things for you. So when you solve in that manner, this that will be more helpful for you. Okay, and apart from that, these are the references which you can follow. Apart from that, many references also mentioned on the NPTEL website. With that note, I will end the today's session. Thank you everyone for joining, and uh, we wish you a very happy weekend. It is a very small weekend for you, but wish you a very happy weekend. With this, I will end the today's session, and I will meet you again in the next lecture. Till then, uh, stay focused and try to focus on your study and try to gain more knowledge. Okay. Wish you a very happy weekend. With this, I am ending the today's session.